Welcome to video 6.2, where we are going to be talking about how to create, read, update, and delete documents in MongoDB. So in this video, we're going to start with just a basic overview of some core concepts you're going to need to understand about MongoDB before we start interacting with documents. And then we're going to learn how to create, read, update, and delete documents. So let's go ahead and get started. One of the first things we need to understand about MongoDB is that nothing exists until we write data to it. There is no concept of data definition language. There is no concept of a schema. So when we start up Mongo, we are going to connect to a database that doesn't exist yet, and we're going to write a document into a collection that doesn't exist yet. And only when we write that data will the collection and will the database begin to exist. So on the one hand, this is really nice because it means MongoDB is extremely flexible as to what we can write into it. However, on the other hand, MongoDB is just going to happily accept any typos or misspellings that we might accidentally put in. So we have to be very careful to be very precise with what we are typing in. It is very infrequent that we would get an error from MongoDB where it tells us that an attribute doesn't exist or a collection doesn't exist or anything like that. MongoDB, for the most part, is either going to fail silently or it's going to assume that you want to write something into a new collection or a new database and just do that. So the takeaway here is just be aware of what's going on here and be careful and make sure you're very precise with exactly what you are typing in. Now, when you launch the Mongo client, you're going to tell it what database to connect to. And again, this database doesn't have to exist. It can exist, but if it doesn't exist, then it's going to just be created whenever we write our first document to it. And of course, nothing exists in this new database. And when we write our first document, a collection is going to be created. Now, a collection is just a group of related documents. So if we wanted to kind of put this into relational database terms, we might think of a document as being kind of similar to a row in a relational database, and a collection being similar to a table in a relational database. Now, documents in a collection do not need to have the same attributes. Every document can look different than every other document. And if we want to see all the collections that exist in a database, we just type show collections. Now, whereas we mentioned the documentation that is online for HBase is quite in-depth and technical and sometimes a little bit difficult to follow, the documentation for MongoDB that you can find online is absolutely excellent. If you just Google MongoDB and whatever you're having trouble with, you are sure to find a lot of good information. There are a lot of MongoDB cheat sheets out there that are excellent reference guides. And the documentation available at mongodb.com is really good. So there's no shortage of resources for being able to troubleshoot any problems you're having with MongoDB. Additionally, Mongo has some really nice built-in documentation. As it turns out, all of our MongoDB commands are really just JavaScript functions. And if you type one of these commands without passing any arguments into it, Mongo is going to show us the source behind the function. So for example, we could type db dot and then the name of any collection we're dealing with, and then a dot and then find, which is one of the commands we're about to talk about. And MongoDB will show us how the find command works. And then perhaps the most interesting and useful is that MongoDB tells us what arguments the function expects to have passed into it. So this is really a very valuable way to kind of get a refresher on exactly how you need to interact with these commands. So in order to interact with MongoDB, we are going to be connecting to our MongoDB server using PuTTY, and then we're going to launch the Mongo client and connect to your MongoDB database. So just like with HBase, I'm going to ask that you put your Blackboard username in front of the database that you are creating so we don't step on each other. So I'm going to now switch over to MongoDB and start creating some stuff. Okay, so here I am on the MongoDB server. So to get started, I'm going to type Mongo mgrimes_UHDB. And so this database currently doesn't exist. And if I type show databases, we can see that there are a couple of built-in databases for MongoDB, admin, config, and local, but this mgrimes_UHDB does not exist yet. Similarly, if I say show collections, well, we get nothing in return. There are no collections yet. So in order to create our first collection, we are going to insert a document. And the way we do that is to say db dot the name of the collection dot insert, and then in parentheses an object. And remember from our earlier discussion that an object in JSON is always wrapped in these curly braces. So if we wanted to insert into the students collection this new student object that has an attribute of name and a value of Adam Baker for name, and an attribute of classification and a value of freshman for that attribute, then we would write this statement here, db.students.insert, open parenthesis, open curly brace, the contents of our object, close curly brace, and close parentheses. So let's flip over to MongoDB and take a look at that. So I'm just going to copy and paste this. All right, so when we do this, Mongo says the right result is that we inserted one new document. At this point, if we say show collections, we see that we have a collection called students. If we say show databases, we see now this mgrimes_UHDB database has been created. Now, if we want to see all of the documents in this collection, of which there's only one document at this point, we can say db.students, which is the name of our collection, and then the find function. And we see we have one document with this document ID, and this document contains this student object with an attribute of name and a value of Adam Baker, an attribute of classification with a value of freshman. So of course we can insert more complex objects, objects that might span multiple lines in our JSON statement. So if we wanted to insert this student, Christy Drake, who is a sophomore, who has 45 hours and then has this address, and note that address is an object that is made up of 4 other attributes, street, city, state, and zip. So this first attribute, name, is a string, and we can tell that because it's wrapped in these quotation marks. Classification, of course, is also a string, as are these attributes, street, city, state, and zip. And then hours is a number, and we can tell because this number is not wrapped in quotation marks. So if we wanted to insert this object into Mongo, I'm just going to copy and paste this insert statement. And Mongo tells us the right result was that we inserted one new document. So now I can say db.students.find, and we see we have these 2 documents with these 2 different object IDs. Now we have quite a bit more data that we want to insert. So this is all in your PowerPoint slides. I'm just going to copy and paste this. And now when we say db.students.find, we see that we have quite a few students in our collection now. If we want to see just how many, we could say db.students.count, and we see here that we have 10 documents in our collection. Now, one thing I want to point out about this ID that has been automatically created for our documents is that this is a really ingenious approach that MongoDB has taken. So Mongo automatically creates a 12-byte hexadecimal key that is pretty much guaranteed to be universally unique. The first 4 bytes, or the first 8 characters of this ID, is a timestamp, which is precise down to 1 second. This is based on the Unix epoch, which we've talked about in some previous lectures. And then a 5-byte semi-random value, which is made up of some information about the machine ID and the process ID, and then a 3-byte increment, which starts at some random seed. So the chances of having overlap of an object ID within a MongoDB server are absolutely 0, but even across MongoDB servers in different environments is very, very small. In fact, the number of possible values of this timestamp winds up being about 18 quintillion, which is an 18 with 18 zeros after it. So a pretty huge number. Now, note that since this ID value is determined on the timestamp, the machine ID, and then a random seed, none of the object IDs that you see in this presentation will match what you see when you're actually interacting with MongoDB. So don't try to copy and paste those in order to replicate these commands. Now, returning to our MongoDB server, if we wanted to use find not to return all of the documents that are in our collection, if we wanted to find a particular document, inside the parentheses for find, we can give this search criteria, which is going to be passed in as an object. Remember, everything we do in MongoDB is dealing with objects. So the query that the find command is going to be used has to be formatted as an object and thus is inside these curly braces. So inside the curly braces, I want to find documents where the ID is equal to one of our document IDs. So I'm going to select that and copy, oops, and now paste that object ID. And when I run this, I get this single object in return, or this single document in return that has this object ID. Okay. I could also have could also search for other things. For example, I might want to return all of my documents where the classification is freshman. And now we have these 4 documents returned where we have students that have a value of freshman for the attribute classification. And this is really just a Boolean test of equality. Now, one thing that is just a little bit complex about writing queries for MongoDB is instead of using the comparison operators that we are used to, like the less than or greater than sign, we have to use the JavaScript style notation for these operators. So less than is $LT, greater than is $GT. On the next slide, and also in your book, there is a list of quite a few of these operators and how to interact with them. So for example, if we wanted to find all of our students that have a value for hours that is less than 40, this is the format we would use. We would say db.students.find, open parentheses, open our object, hours, and then we're going to open another object and say $LT:40, close that object, close our search query object, then close our parentheses, and we find these students that have hours that have a value for hours that is less than 40. Now, if we wanted to find all of our students that are, for example, from Texas, we're going to create our query object and look for address.state, because recall state is a subattribute of the address object, and we are going to look for a value of tx. Close this object, close our parentheses, and here are all of our students who are from Texas. Now, if we want to negate that, we can do that with $NE. So we're going to say address.state, and then we're going to create a new object, which is the negation of Texas. Now, when we run this, we see we have our students that have a state other than Texas, in this case, Tennessee or Oklahoma, or this very first document we created with Adam Baker, who doesn't have a state at all. Of course, we can also have more complex search criteria, and there are going to be multiple ways that we can write the same type of criteria. So imagine we wanted to find all of our students who are from either Texas or Tennessee. So we could say in, and then create an array of strings that we are going to search. So we're going to find any students that address.state is in this array of TX and TN. So now we get all of our students from Texas and Tennessee. Now another way we could write this is with the OR operator. So in this case, our query object is going to start with our OR operator, and then we're going to pass in an array of Boolean queries. So the first one of those, which needs to be an object, is going to be address.state is Texas. And the second is going to be another object, which is address.state is TN. Okay, close that object. And let's see, I messed that up somewhere. Let's try again. We're going to create an object that we are querying here. It's going to start with our OR operator, and we're creating an array of objects that we're looking for a true evaluation of. So the first one of those is going to be address.state is Texas. And the second is going to be address.state is Tennessee. Close that object. There we go. That worked better. Everyone makes mistakes sometimes. So this OR evaluation was just the same result as doing our IN operation. So just like with SQL queries in a relational database, there are often going to be multiple ways that we can write a query to get the same results in MongoDB. Now finally, while there is no like operator in MongoDB, we can use regular expressions in our find queries. So in order to indicate that we are evaluating a regular expression, we just wrap the search term in forward slashes, and this is going to find us any documents that have a value for address.street that contains the string street. So this is going to give us people that aren't living on avenues and boulevards, only that live on something like North Main Street or South Pine Street or West Street. Right? If we did AVE for Avenue, we would find students who live on Oak Avenue or Smith Avenue or Downtown Avenue. Okay. We might also want to do something like this to find students that have, in this case, this is going to find last names that start with B because we're looking for a space followed by a capital B. Right? So we get Adam Baker and Angela Bradford in this case. So these are some examples of how we select only certain documents. This is similar to our select relational algebra operation in a relational database. So here we have that cheat sheet of some of the operators that we can use. So this is here in your PowerPoint slides for your reference. So now we're going to move on to projection. So projection, of course, just like in a relational database, is going to only show the attributes that we are interested in. And in MongoDB, projections can either be exclusive, saying that we want to project everything except a certain attribute, or they can be inclusive and say we only want to project these certain attributes that we list. And one thing to note, we do have one special attribute that is going to act a little bit differently than our other attributes, which is the ID field, and that is always going to be returned unless we explicitly exclude it using an exclusive projection. So let's go through a couple of these examples now. So in one of our previous examples, we returned all of the documents where we had a value of freshman for classification. Now, imagine we didn't want to return this ID field. We can just add another object here as part of our find and say underscore ID colon 0, and now the ID is not returned. Now this 0 that we passed in here is just a Boolean, so instead of 0, we could also say false, and we'll get the same result. Now let's say we wanted to see all of our freshmen, but instead of all of this information about their address and things like that, we only want their name and their classification. So now we get a little bit more of a simple response where we have just these attributes that we're interested in, name and classification. If we wanted to get rid of the ID value, we could exclude that. And now we just get name and classification. And again, these ones and zeros are just Booleans, and we could say, instead of 1 and 0, true and false, or any combination thereof. And if we also wanted to get states, we just need to say we want address.state, and that will be 1. And now we can see that the names and classification and states of all of our freshmen. Now imagine we just wanted to project a subset of attributes, but for every document in our collection. In that case, for our query object, instead of having an expression here, we just need to pass a blank object into find. Okay, so just an open curly brace and a closed curly brace. And when we do that, now we see every document in our collection, the value for name, the value for classification, and the value for state. Updating a document in MongoDB follows a very similar format to inserting a document or reading a document. We say db. The name of the collection .update, and then in parentheses, a query object, an object describing what you want to update, and then optionally a Boolean value for if you want to upsert in this update, and a Boolean value of if you want to update more than one document at a time. So what upsert means is if there is no document that matches the object you passed in for query, the update is going to insert a new document. So the default, if you don't specify anything for upsert, is false. And multi tells MongoDB that we want to update multiple documents at the same time. So if you don't specify true for multi, then it's going to only update the first document it finds. It's not going to update more than one document. Now, one kind of tricky thing about updates in MongoDB is that MongoDB expects that when you update a document, what you really want to do is replace the entire document, not that we want to change the value of one single field. So we have to be very careful to pass the correct operator into our update statement to tell MongoDB, no, we don't want to replace the entire document. We want to update a single field within the document. So let's see what that looks like. Okay, so let's clear this out just a little bit so it's easier to see what we're doing. And I want to return just the name and state of all of our students. Okay, so here we have our 10 students. And let's say for a moment that Christy Drake has decided to move from Texas to Arizona. So we want to update that document, and we might be tempted to take this approach, db.students.update, where name is equal to Christy Drake. And this is, at this point, assuming that this is a unique name. It would really be better if we identified the document based on this ID value, but just kind of for clarity of this example, I'm using her name. And we want to update the address of this document to be or the state of this document to be Arizona. Now, like I just mentioned, MongoDB expects that when we do an update, we want to replace the entire document. So when we do this, we're going to see that the update found one match and modified one document. And now when we look at our students, we find that we don't even have a student with the name Christy Drake anymore, because Christy Drake's entire document was replaced with a document that just has this one field of address, state, Arizona. So that certainly isn't what we wanted to do. So I'm actually going to remove this so we can start over and do better by saying db.students.remove, and then I have to pass in my object that I want to remove, which is going to be ID this. Okay, so now we removed one object. If we run this same find command, we see that that is gone now. And I am going to reinsert Christy Drake as she was before. Okay, so now we once again have Christy Drake with a state of Texas. And if we want to keep the Christy Drake document intact and only change the value of the state attribute, what we have to do in our update statement is put $set in front of the object that's describing the update we want to make. So now when we do this, we see number matched is 1, number modified 1. When we run this, we still have Christy Drake, except now she has a value of Arizona for state. Okay, now here's another interesting thing about update. Let's imagine for a moment that we were changing the format we want to store our data in, and instead of having the 2-letter abbreviation for the state, we want to spell out the entire state. And this looks like a query that very well might do that. We want to find all of our documents that have a value of tx for address.state, and then we want to set address.state equal to Texas for all of those documents. Okay, this seems good. We run this, and notice that MongoDB says we only matched one document and only modified one document. Let's look at this again. Well, it only modified the first document it came across. And if we run this command again, we'll find that it just did that again for the very next document that it found. So what we actually have to do here is pass in a value of true for the multi argument. So in our update statement, it first expects a query, then the update that we want to make, then whether or not we want to do an upsert, and in this case, I'm going to say false, and then if we want to update multiple documents at once, and I'm going to say true. Now, when we run this, we see that MongoDB says we had 4 matches and 4 updates, and yeah, sure enough, we were able to update all of that. So let's go ahead and do this for Tennessee, Oklahoma, and Arizona. And now we have all of our states spelled out. This is great. But now imagine if we were just doing this for all 50 states. So let's include Mississippi in the mix. And note that we have a value of false for upsert and a value of true for multi. So if we had multiple students that had a value of MS for their state, they all would have gotten updated. But in this case, we don't have any documents that have a value of MS for state. So 0 matches, 0 upserted, 0 modified. Everything is in the exact same state it was in before. But if we change the value for upsert from false to true, this is telling MongoDB if we don't find any documents where this expression evaluates to true, we want to create a new document that has a value of Mississippi for this address.state object. So now when we do this, we see we have 0 matches, 1 upsert, and 0 modifications. And now note that we have a document that doesn't have any information in it except for this one attribute address.state, which has a value of Mississippi. Now, is that what we wanted to do? Maybe so, maybe not. It depends on the business problem that we're trying to solve. Now, there are quite a few other operations that we can invoke with update. We just looked at set. We can unset, we can increment, we can pop, push, pull all, a lot of nice things to experiment with. Let's take a look at the increment operation real quickly. So, for example, if we wanted to take a numeric value and add some value to that numeric value. So in the case of the number of hours that a student has completed, we might want to do something like this. So let's say db.students.find, and we want to find where name is Michael Nash. And we see that Michael currently has 33 hours completed. So we can update that by saying db.students.update Michael Nash, and we are going to increment the value of hours by 3. And now when we look at Michael Nash again, we can see that hours has been incremented from 33 up to 36. So there are a lot of really useful things you can do with the update function, and that's something I would encourage you to play around with a little bit. And of course, the last operation that we can invoke upon data is to delete. And as usual, be careful because there's not much of a safety net around deleting. If we want to delete just a single document from a collection, we say db dot the name of the collections dot remove, and let's just get rid of Michael Nash. And it says here that we removed one document from our collection. Of course, if we now find all of our students, we see that Michael Nash no longer is in this collection. If we wanted to get rid of our collection altogether, we're going to get rid of all of these student-related documents. We're going to say db.students.drop, and true is the result. And now if we show collections, we see that nothing is there. Of course, if we try to query this collection, we're going to get nothing in the result. And since this was the only collection in the database, when we dropped that collection, the database was also dropped. But if we wanted to drop the database while collections were still there, we could say db.drop database, and the database would be dropped. So that's it for how to create, read, update, and delete data in MongoDB. I hope you found this useful, and we'll see you next time.